In this video, we are going to adjust our column operating condition. So we have this atmospheric distillation, but here we have only a condenser. We didn't add a reboiler. Okay, so if we go to this board and we look here, you'll find out that always your atmospheric distillation column has a feed, and at the top you will have different products, but at the top you will have a condenser to lower the temperature. Okay, and from the condenser you will have a drum. At the top you will have light gases produced, and from here you will have a naphtha. You can take all the naphtha as the outlet or return some back as a reflux. Also you separate kerosene, diesel, atmospheric gas, oil, and from the bottom you have your residue. But the same case as the top, you will have here a reboiler or a fire heater to increase the temperature. So this is a fire heater. Okay, sorry for this one at the top. This one here, the arrow should be up because we are lowering a temperature. So this is a condenser, and here we have a stream. This is called a residue. Okay, and some of it return to the atmospheric distillation to strip. So why I'm discussing this now? Because we have 2 points returning to the atmospheric distillation. The first one is cold stream. Okay, this cold stream lowers the temperature of the column, and the second point is a hot stream coming from the reboiler. This is a hot stream which is responsible for controlling or increasing the temperature of the distillation column. So if we want to lower the temperature, we increase the duty of the condenser. If we want to raise the temperature, we increase the duty of our reboiler. Okay, so this is a feed point. Here we have a feed divided the column into 2 sections. So this is 2 sections. The section with the top here is a rectifying section, and the second part is called a stripping section. For our case that we are discussing here in Aspen HYSYS, we don't have actually a stripping case because we don't have a reboiler. So in this case we are going to add a reboiler. So to model this atmospheric column, you need to utilize a refluxed absorber template. In this case we actually utilized it. Okay, but refluxed absorber doesn't have a reboiler, so which is some kind attached to having a distillation column. So we are going to create our reboiler, or instead of adding a reboiler you can add an energy stream. Okay, so here we are going to define an energy stream here, and we open this stream and we are going to call it our trim energy. This trim energy is like a replacement for having a reboiler. We don't have any information other than we are having some energy. So why we are not going to add something like the heat flow or the temperature? Because in this case we are going to do the heat balance, and the rest of heat that we need to add will be added in this information. Okay, so we need now to go to here to our atmospheric distillation, because we want to connect this stream. So from design connection you go to these are the internal, and our trim stream actually is an internal. So we are going here to add our trim stream in this section. So the stream here will be our trim energy. This is the trim energy, and after adding it, our column will be unconverged because you have added a new degree of freedom. You have added an stream. So to now we should go to our monitor and check which new spec is added. Okay, in this case we need to order them, and the new material stream that we add, and it doesn't have any value. Okay, actually it didn't add any new material stream. Okay, yeah, we don't have any new material stream. It's just unconverted because you have 1 degree of freedom that you need to add, which will be, in this case we are going to define our energy stream as a spec. So we are going to add a spec from here, And in this case, we are not given, as I mentioned before, the energy stream doesn't have a value. our energy stream is not fully defined, so 1 degree of freedom appears. So in this case we are given another information, which is a column liquid flow. So in this case we are given a column liquid flow, okay, and we are going to add this spec. After adding it, this will be shown we have our liquid flow called overflash, because as I mentioned before, we have a stripping or overflashing. So we are going to add the overflash that happen after adding this our energy stream, and it will be at tray number 27, okay, this tray. And the flow basis is a standard volume. The value that I have is standard ideal volume, and its value is 23 meter cube per hour. So I have added this value, and it's now fully defined. So we need to make sure that we have an active flash, okay, or overflash. So now we go here, we have our overflash, and actually it's active, and the degree of freedom equal to 0. So if I'm going to group all the active, those are all our active specs, and now we need just to run our column to make sure that it will be converged. Okay, it's now doing a calculation and solving. Okay, so this happened. This isn't natural to happen, to keep solving for a long amount of time. So what does it mean? This might mean that we have an active spec that we needed to be inactive. Okay, so now we are going to stop and again regroup our active, and in this case we are going to look we have added before a reboiler. Okay, so now we don't need this information because the ratio of the reboiling isn't important. Now we are introducing another stream, so in this case our boil up ratio will not be important. Okay, we have already defined it to be 0.75, but now it is not that important. Okay, so we are going to uncheck it and make sure it's estimated. So now it's estimated. So now we have our kerosene side stripper boil up ratio inactive. So again we are going to group what is active, and we are going to look for our kerosene side stripper reboiler duty. So for kerosene reboiler duty, we didn't have any information about it, but now we are given it. So instead of being given 0.75 as a kerosene boil up ratio, now we are having a duty. So we are going to add its value to be 7.9 E with the power 7 kilojoule per hour. Okay, so now this value will be active. We need to group these values, and we make sure that our duties that we added now should be active. This one should be also active. Okay, after activating it, this degree of freedom must equal to 0. Okay, so we need to make sure that it will run. Okay, column atmospheric doesn't have enough specification to run. Okay, still the degree of freedom equal to 0. So again, arrange them. This is actually a problem if we have a lot of specs. So I need to make sure that if each spec that I added, okay, this one we have added it, but it is not active. That's why the degree of freedom is still equal to 1. And again group them. Okay, after grouping them as a top, we need to make sure that each value, okay, this one, as I mentioned before, we are doing uncheck, and okay, so now we have our specs. Again we are going to run. Okay, again we have the same error message, so I need to double check. So again this value is not added, so I'm going to check it again, and this time it works, and actually it's converged. So now we have defined some parameters related to our distillation column. So I want to check with you that in the connection we have inlet streams and outlet stream. the difference between the inlet stream, it's any material stream or any energy stream. It could be material or energy stream that is flow into the column. So that is entering the column itself. The outlet stream is any material stream or any energy stream like this one that could be exiting or flow out the column module. Okay, we also could have some internal streams and external streams. Internal stream if it exists inside the column sub flow sheet, which means, okay, if I go inside, enter the flow sheet, what is inside here is called internal stream and external stream because it's inside the subflow sheet. So you have your main environment, it has the inlet and outlet. The difference between the inlet and the outlet is related to the column module and the column subflow sheet. So if they are asking you about something like the kerosene here, side stripper energy, this is it's entering, okay, so it's an internal stream. Something like this one, like the atmospheric residue, this is an external stream because it exits outside of the column flow sheet environment. So you will find it in the parent exiting out too. So it's like this one. Okay, now we have finished. I am seeing this one empty. This one is not working, so I need to open here to check the problem. Actually it's converged, so check here, it's on hold and then active again to make sure that it's really active. Okay, now I'm entering the flow sheet to check what's actually happening here. So we have our atmospheric residue temperature. Actually it's running, so we have the temperature here is 376.6 degrees Celsius. So it might be an error from the software itself. So if I go back to the parent, okay, it's still not defined, so I can enter it myself, unknown temperature. Okay, so the temperature here is 376.6, and actually it's okay if you have some problems because a lot of problems could happen. Okay, so here it will keep asking about information, so I'm going to delete the temperature and go back here. After it's changing from on hold to active, it runs directly. Okay, so sometimes a lot problems happen in the software, so just be flexible and try to read the error message, and at the beginning check the solver. Most of the time the problems happen if the solver is on hold.